Assalamu alaikum. Welcome to the CSITEd Experts Data Science A to Z Bootcamp. In the previous video, I showed how to develop a single linear regression model using Python sklearn's built-in library, library. So actually, we discussed this. We discussed we we developed a, linear regression model. This on the left side, you see on the left side, in this image on the left side, the red line is the linear regression model that we developed with the training set on the, and on the right side we developed our we verified our regression model with our test set. So if we go back to our program, to our original program, so you saw that we ran this program and it was working good. So this was what we did at the last time. So but one of the limitations of this uh, development process of using the built-in linear regression is that, did you notice that we tried but we could not print this regressor? So if even we want to print this regressor, we see that this is a built-in object and it was not created as a variable. So even I cannot do this, right? So for instance, if I wanted to print my regressor, it is not a variable, not something as a variable, so I cannot do this. Like, so this is one kind of limitation. Is not a is that there are other limitations that we will go through soon. That for instance, you see that in this case I have only this is a very simple data set. I have only one independent variable, that is the experience, and I have another dependent variable. So in this case it is difficult to use multiple independent variables here. So in that case we need to use multiple linear regression. So we will discuss multiple linear regression later, but here in this video we will discuss how to create our own regressor. Actually, the regressor, we use the built-in regressor. Do you have any curiosity that you wanted to learn how this regressor works and what are the methods or functionality of this regressor? If in order to understand this, although we need some in-depth programming experience and as well as vector analysis and linear algebra, your previous knowledge, your not background in vector analysis, vector algebra and linear algebra. So we will discuss those the preliminary and foundational knowledge, foundational stuffs of vector algebra and what is that called, linear algebra, and vector operations and matrix operation later. But in one of my previous videos, actually I showed how to do matrix operations. I believe by this time you know matrix operations, like like for instance, in this video, basic matrix operation with Python Anaconda Spider. Actually, I urge you to watch this video if you do not familiar with the basic matrix operations, like for instance matrix matrix addition, matrix multiplication, matrix transpose, and inverse operations. We need these operations. Actually, we need to use this in order to understand our today's lecture of developing our own regressor. Okay, so let's get started. Actually, when you understand the theories behind this, how the linear regressor work, this will be pretty simple for you. But for now, let me give a brief, very brief uh, description how a linear regressor work. Actually, for instance, the main, if you see, the main idea behind the linear regression is to write a linear combination of x1, x2, x3, that is xd. This is my independent variable sets. This will be a vector of d dimension. Okay, and then we will use this y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus dot dot plus beta d xd. Okay, and then where beta 0 is the initially of an offset and initial offset, and beta 1, beta 2, beta 3 are the for instance weight of each of the variables. Okay, for instance, so if I have a healthcare data set, and if we have glucose level, we can compare glucose level equal to beta 0 plus beta 1 times height, then beta 2 times weight, and beta 3 times age, and beta 3 times gender. That means glucose level of a person depends on all of these: height, weight, age, and gender. Okay, so then once we get this beta, then it's easy to find y equal to x transpose of beta. So our goal will be that we discuss in the theory section to determine the beta. Each of the betas we need to determine. So when we determine the beta, then our prediction y, dependent variable prediction y, is easy to calculate. So beta, actually the beta we will be calculating, beta will be x so actually beta will be here, actually this part, the beta will be here, beta will be this part, x transpose x whole inverse x t y. Then my prediction y will be my x t. This is a x, means this is small or lowercase x, this is a vector. Okay, then when we will have a vector equal to column wise, this is one column will be vector, and when you transpose is, then it will be matrix, and then you will do a matrix multiplication with your beta, then we will get our predicted result. So although this at this point it may be difficult for you to understand, but when you understand the theories behind the linear regression and the basic theories of linear algebra and matrix manipulation, matrix operation, then it will be easy. So let's go to our code. So okay, so make sure that you have this setup, you have set up this this regression and then simple linear regression as your home directory of data source. Then select this one, then let me open my file. So this one, actually in this video we want to discuss how to calculate a regressor, right? So our own regressor. Let me open okay, open this one. So here actually here is my entire program. So I will split this video in actually in let me see if I can do it in one video or I need to split it here. So until up to this part, actually it is very simple, that I think you understand this from the previous section. If you understand this, for instance, this is my same experience salary data from, this is same from with my previous videos that we discussed. Okay, let me close this. Okay, and x is my data set matrix, and y is my, here actually this y is here, this y is my dependent variable. So let me clear everything and go step by step. So if I run compile until this, then you see my data set has 50 rows and 2 columns. Okay, same data, and I have my x as a matrix, and I have my y, this is also a matrix 50 by 1. That this x is my independent variable. Okay, although it is a matrix, but although it has only one column, but this still, this is a matrix, and this is, okay, so this is y. So here this is a matrix. So in this case, remember that although previous, in our previous video I mentioned that it was doable to make it as a vector like this, but it is not like this with mentioning only one column, but it is not possible here. So you must make it as a matrix. For now we will discuss this theory section, why do we need to this, because since y is a transpose matrix of the y itself, actually y is a transpose matrix. We will discuss this later. So in this, now if we actually got our data set, if we draw our scatter plot, we see that we got same scatter plot, and here is the behind the formula I just discussed. We need the formula is that x transpose x whole inverse xt. Remember this for now, please try to remember this. Okay, so actually from here it will be starting from here. Let us start from the x is my matrix extra. We will discuss, we will add this part later, the lowercase x. Okay, so here is my x. We know that where is my x, right? This is my x, this is my x, and x transpose is, we can use np. Np is the numpy library. We discussed previously that how to use numpy to transpose a matrix. So we got x transpose as this, and then after that we will multiply x transpose with x. So here x transpose multiplied by x. So we are getting, although I gave it a weird name, you can give whatever name you like. So I got x transpose x over here. Okay, then x transpose x inverse, then we need the whole this part, x transpose x inverse, whole inverse. So then we use len alz dot inverse method that we discussed in our previous lecture, that how to inverse a matrix. So we got this inverse matrix, the whole inverse, we got whole inverse of this, whole xtx whole inverse, we got this. And now what do we need? We need to multiply whole inverse this by xt. X transpose, that's we got this, we got whole inverse by X transpose, we multiplied it. Then our regressor will be, that is my regressor will be X transpose X whole inverse times matrix Y. So this is our, you see, this is our whole Y. This is our, this part is our, this part is our, actually this part. If I take a take a screenshot, so this is the part, actually X transpose X whole inverse, that's X transpose Y. This is my beta. So we are calculating this through our program here. Okay, so once we calculate this, then we got our regressor, right? So until this, let us compile until code over here until this. So now we got our regressor. So let me print one by one. So this is my matrix, X matrix. Okay, so all of the ages, experience ages, okay, experience, okay, and this is my X transpose, this is my X transpose, this is my X transpose times X, and this is my X transpose X inverse into X transpose, and this is my regressor. At this point, if I print my regressor over there, you see that I got a comprehensive regressor as a number. So I can print this regressor as a number. But previously, do you remember that we could not, with the built-in regressor, we did not have this kind of regressor value, right? So now once I have this regressor value, then I can use this regressor with my transpose matrix, okay, with my matrix. So if you see that the formula is here, the formula is here, so we will use, this is my predicted value y hat equal to xt beta. We got beta, the regressor, beta star means regressor. Then if we do X transpose, then actually we will be able to find our predicted value. So in this case, so we will get, for instance, this is my feature, okay, for instance X is my given X, and then we want to predict this is experience in year, and we want to predict salary. So if we use this formula, then it is fine, working fine. Now if we print our X predict and X feature and X predict Y predicted, then we will get our result. That means here my using my regressor this, okay, and for an employee with 4-year experience, the salary, annual salary is about 53,000 per year. Okay, so let us run the other few this line. So this is the will be our predicted value, predicted Y salary for 6-year experience, and this will be our predicted values, predicted annual salary for 8 years experience. So we got this, right? So we got for 4 years we got this. So 4 years, remember that for 4 years, 6 years and 8 years. So if we make this a little bit larger, and let me bring it side by side with our previous result. Okay, so what did we got in our previous result, previous model? We got in, this is our previous model, we got Okay, so according to our previous model, so let me do side by side and compare side by side. For 4 years of experience, our previous model says predicted that the annual salary was about 60 up, but it predicted 52. At this case it was 53, right? For 6 year experience, our previous model predicted about 80, 81 maybe, or 80, 82 or 81, but it predicted about 80. For 6 years is pretty close. And for the 8 years of experience, our previous model predicted 103 4 something, 103 and 4 thousand per year. And here our new model predicted 105. So 105. So although these are pretty simple, but still there are scope that we can compare each of the two models and we can decide which model we should use. Okay, but one of the thing that by using this model, okay, by using our own calculated regressor, that is the theoretically foundation, theoretically taught. If you take any foundational machine learning or data science or data mining or data analytic course at any university, as in university or college, then you will learn this, how to create a regressor. And there are some advantages of using this kind of regressor is that we will discuss in our next videos. That this model has a this model has a lot of advantages than our previous models. Okay, one of the advantages is that in our previous model it was hard to use to have multiple columns in our independent matrix. That means that was not easy so far. Although there is another way to do multiple linear regression, but that is a different case. But in our next videos that we will discuss how this linear regression works and how we can use this linear regressor in order to process our data for any independent data sets. For instance, I can show quickly just to give you some heads up. So let me copy this regressor and let me copy this regressor until this part. Let me copy this part and save this part, and let me open our another program that we will discuss later. That, for instance, this program. So it has, you see, this program. So it has a data set of 50 rows and 8 columns. That is a comprehensive salary. That means this salary is comprehensive. That in this salary it is counting, for instance, a company is counting experience, education, years of education, performance, and dedication to the company, and maybe the languages an employee knows, and maybe its gender, and maybe its ethnicity, and all of these are combinedly considered as an employee's annual salary. So in that case, our regressor will be a complicated and compound that will be developed based on this set of 7 independent variables. So in that case, if we, for instance, run this the same way, and if we do the same way, then our regressor will work, and this, in this case, we will get our result using the same method. Using the same method, we can find our predicted value and our regressor. You see that we got our regressor. That is my regressor. If I run this regressor again, so that is, we got a, you see, different regressor. We got different regressor. One of the first regressor is for what? For the first independent variable. What was my first independent variable? Remember that, experience. Second regressor was for my education. Third regressor was for my performance. Fourth one for my dedication. Fifth one for language, and then so on. That means using this formula, we can use any data set that has multiple independent variables, but using previous model it was not possible. Okay, so let us compare. So we have I copied our previous result. Okay, I copied our previous result, but for this one, let us see that we have a different, although the data set was same for 4-year experience. Previously, for 4-year experience, we got 52,920, but this time for 4-year experience, let me do it side by side. So previously, when we consider only years experience in year, then we, for 4-year experience, we got 52,920. But this time, when we are considering both year, then years of study, how many years he studied, 14 years studied, and 3 would be the, what would the next one, remember, performance, dedication, language learned, and then maybe gender, ethnicity. By the way, this gender is converted into 0 and 1, maybe 1 for male and 0 for female, or vice versa. Ethnicity, maybe this one. So for this one, we got 65,000. That is more accurate. Okay, and for 6 years previously, we got 79,000, and for this time we got 83,000. And for 8 years we got 108,000, and over here it was about 103,000. So this means that this regressor is better than the built-in regressor. And for now, after mostly we will discuss how to develop this regressor, and how to actually theoretically, and how to use this. But for now, I want to give you a homework that is your own task. That is, you see that in our okay, so in our folder, so we have this both this what is that called, experience salary. Okay, experience salary, and we have also our comprehensive salary, and we discussed in our previous programs that how to develop our regressor with previous model, and I also discussed in this model. Now you try and practice yourself and verify and compare the result from you got from your both models. Then you will understand the difference between the previous version and this version of uh, calculating or making a regressor model, and try to find if do you see if you find any limitation of model this model. Do you see any limitation of this model? Try to understand this. And uh, okay, then in our next video we will discuss more. Thank you so much. Until then, happy data science and machine learning. Thank you so much. Bye bye.